Hello everyone, welcome to happymath.com. So today's topic is rational function. Okay, what is the rational function? The rational function means any function is based on fraction format like this. And then these fx and gx, they are basically any expression. So it can be a number, it can be a variable terms, so whatever like that. Okay, some examples. So we can have maybe y equal to 1 over x. As you see, there is a fraction form, right? And then like fx equal to maybe 2x over x minus 4. They're also a fraction form. And then maybe gx equal to 2x over maybe x squared plus 1 like that. Like this, all these examples. So when you look at each function form, there are always fraction here. Okay? And especially, please look at the denominator. The denominator, they always include the variable. Okay? So that's basically rational function format, basically. The numerator, it can be anything. It can be a number, it can be variable term, whatever. But the denominator must include variable terms. That's the rational function format. Okay? So now you know that the variable, the meaning of the variable. Okay, variable means it can be random value, so we can input into the variable any numbers. Therefore, the rational function, we have one of the restriction, which is gx cannot be 0 here. Okay, gx cannot be 0, which means any x value makes 0 of the denominator, then there will be a function's restriction, which means no real value exists at the x equal to 0 of the denominator. That's what this means. Okay. So this function case, because we have x on denominator, so we can make x cannot be 0 basically. That is basically our restriction value. And then this function case, so fx equal to 2x over x minus 4. So x minus 4 cannot be 0. It's very important anyway. So please remember that. So you solve for x. And in this case, x cannot be 4 like that. Okay? But what about this case here? This case, we can set up. So x squared plus 1 cannot be 0. But in this case, x squared cannot be negative 1. So you know that x squared actually cannot be negative value. So it is not factorable. Therefore, this case, no limitation exists. Okay? Yeah. So always like that. Solve for denominator value for the variable, and then find out which one makes that equal to 0. So that's the key concept of the analyzing the rational function. All right? Okay. Then let's look at a few examples. So find the domain of the functions. Okay, so first one is fx equal to 4 over 3 minus x. Okay, so key point, please remember the numerator doesn't matter to determine the domain value, because a numerator can be 0 or negative value, positive value, it can be anything. But denominator, we have to avoid max time equal to 0. Okay, so now we can I just bring out this one. So 3 minus x cannot be 0, and then let's solve for x. So you can subtract negative 3 here, then negative x cannot be negative 3, so divide by negative 1, then x cannot be 3 basically, right? Therefore, A answer case, domain equal to all real numbers, but x cannot be 3. Okay. Interval notation you can write. So open the parenthesis, negative infinity to 3, the union, and then 3 to infinity. There will be domain value for a function. Okay. Then let's think about b function. So kx equal to 2x plus 1 over x squared minus 4. Should we care about the numerator to determine the main value? No, you don't have to. Okay, we always care the denominator. Okay, so I'm going to bring this out here. So x squared minus 4 cannot be 0, which means x squared cannot be 4. So take square root, and don't forget plus and minus. So x cannot be plus and minus 2. Okay. So from here, you can also use in factoring. So this becomes x plus 2, x minus 2. So you can set up x plus 2 cannot be 0, and x minus 2 cannot be 0. Therefore, x cannot be negative 2, and then x cannot be 2. You can calculate this way too. Anyway, so we found those two x value makes the denominator equal to 0, so we have to avoid them. Okay? Therefore, domain becomes all real numbers, but x cannot be 2 and then negative 2. Interval notation, we can write, so negative infinity to negative 2 union, negative 2 to 2 union, and 2 to infinity. That will be the answer for this question. Okay, and let's look at maybe a couple more examples. So px equal to x minus 6 over x squared minus 36. Okay, let's find the domain of this function. So whenever we determine denominator, again, we only care the denominator. We don't care numerator. We only care denominator. That's the key point. Okay. So this case, you can bring out x squared minus 36 cannot be 0. Okay. So you use maybe factoring form, then this become x plus 6 and x minus 6 cannot be 0. Okay, so this becomes x plus 6 cannot be 0, and then x minus 6 cannot be 0, right? So solve for x, then x cannot be negative 6, and then this become x cannot be 6. Therefore, domain is all real numbers, but x cannot be 6 and negative 6. That's the answer. And that interval notation, we can say negative infinity to negative 6, negative 6 to 6, and then 6 to infinity. That should be the answer. But look carefully here. You may think, what about this value, right? So now here, I can rewrite this px equal to x minus 6 over x plus 6 and x minus 6. So now we can cancel these two factors. So we can rewrite this 1 over x plus 6, right? So you may think only this is our limitation value. So x cannot be negative 6 is the only restriction, but that's not true. Okay? Even though we have the same factor between numerator and denominator, because it was located on the denominator already, so you shouldn't care about this. Okay? Then, what do you call this kind of value? with this kind of factor. So we can write this is the removable undefined value. Why? After we simplify, we cancel this out. We remove them, right? So those are removable undefined value, but it affects determined domain value. Now x plus 6, it still stay here. So even though we simplify that, it stay still on denominator. So this kind of a value, we just say that non-removable undefined value. Okay? So please don't be confused. When you determine the domain value, no matter what, we can factoring out and cancel out whatever. We always take care all the value from the denominator. That's the key point. Okay. So then, last question here. So Rx equal to x over x squared plus 25. Okay, same thing. I don't care numerator to determine domain value. So I'm going to bring out this to side. So x squared plus 25 cannot be 0. Okay. I don't think it's factorable. So I'm going to just move 25 on the other side here. Then x squared cannot be negative 25. And then you know that square value cannot be negative value, right? So which means no real value exists. Which means this function, this expression is not factorable. Therefore, this case, domain is all real values. So interval notation, you can write negative infinity to infinity. So that's the answer for this problem. Okay? So today we talk about determine domain of the rational function. So next video we cover to find the value of the rational function, and then maybe we also draw the graph. Okay? Thank you. Bye.